binary numbers. Number 1, 2, and 4. However, number 3 is not a binary number. So there's ways to introduce topics, even in, higher level topics or base level things like computer science type of things, using something as simple as this. So I wanted to do that just to get into it. We're going to do a couple of computational thinking classroom experiences. I'm going to talk a little bit about who I am, but once again, I'm looking at that clock and I want to fly and give you things more than do all of the talking, because that's not my style. So I'm Alan Antoine. I'm the Director of Computer Science Education Strategy at the University of Texas at Austin's Advanced Computing Center. I work at UT Austin. Hook 'em horns. We're in the Final Four. Might win the national championship. Hook 'em. That's the thing, right? I love increasing numeracy skills, inquiry-based instruction, culturally responsive teaching strategies, computer science teacher preparation. I really believe in computer science across disciplines and computational thinking across disciplines. I was a 2023-24 CSTA Equity Fellow with a couple of awesome individuals who I've seen throughout the day since I've been here this morning. So look into that. We do a whole bunch of things in computer science. Some things I really believe in: building relationships with your students, using technology. You wouldn't be here if you didn't think about that. Collaboration. I just mentioned collaboration as a big thing. Student motivation. Really thinking about that, and student inquiry. Letting students actually have some productive struggle where they try to figure out things on their own instead of us just giving them the answers. So, and yeah, being true to yourself. I love to put that in there as well. So what we're going to do real quick, I'm going to go to Flippity. And I had I'm going to get to that next thing in a second. I'm going to go to flippity.net. If you guys are familiar with Flippity or not, as you're going to hear me say a bunch of times, I'm going to throw it in the chat. So I'm throwing that in the chat right there. And we're going to go to Flippity. So we're going to randomly select, and I'll talk a little bit about why we're going to use random selection, but it's a big part of doing Thinking Classroom. So I'm going to put everybody's names in here. If we had a little bit more time, this is when I would be having everyone introduce themselves, and we would be talking about each other and kind of building a little sense of community. But since we don't have a whole bunch of time, I'm just going to throw the names in that I see, and hopefully we still are able to build a sense of community just in a little bit more of a rushed way. So what we're doing here, I've generated a random name picker. Okay, we've got all of this. We're here, we're in the game. I'm gonna go ahead on. Oh wow, I didn't know it was that loud. I would have hit mute. Max, give me a number between 1 and 10.
Let's go with 7.
7. So when you get into the group that you're gonna be in, I just want you to know, I didn't come up with this group. I wouldn't have did this to you. I would have let you go wherever you wanted to. But Max, he said 7. So I mean, I can't do anything about that. I have to respect Max's decision. Since we have let me see, I'm doing my math all wrong and funny. We got 13 people. Let's just break into group. 4 groups. Let's go to 4 groups. So we're gonna have 4 teams. Since he said 7, 1, 2, 3, 4, 5, 6, 7. So these are our teams. These are the groups we're gonna go to. Quing, Max, Danielle, and Angela. Don't go there yet, but I'm going to ask you in a second to go to breakout room number 2A. See, as though we have, you remember Ed mentioned that there's a bunch of different breakouts. The 2A, 2B, those are for us. So Quing, Max, Danielle, and Angela, you're gonna go to 2A. Marco, Yinping, and Donna, 2B. Joelle, Violet, and Lisa, 2C. Sandra, Gloria, and Melissa, 2D. But what are we gonna do in the breakout rooms? Let's look at it. I'm gonna ask everybody to approach this following question. Okay, well, I'm gonna ask you this real quick. In the chat, I forgot, I do want to get a little bit of feedback in the chat. Tell me, do you want a tough problem or do you want a manageable problem? It's up to you. Up to you. More people tell me, how much thinking do you want to do on Saturday morning? That's up to you. Listen, I'm not gonna make that decision for you. So tell me either tough or manageable in the chat. Once I get a couple of people, the first one who gets 3 votes, that's the direction I'm going with it. Let's see. Manageable. I got one man. Y'all want manageable problems this morning? I'm not mad at you. I said I would tell y'all a little bit about my morning. Yeah, it's a morning. I'm doing this because I love doing these things for my people, but I just want y'all to understand that I am in the throes of doing other things right now. Oh, well, this is all off, so I can't even do it right now. I'll do it later. So we're gonna do the manageable problem. That's cool. So I'm dropping this in the chat. We have everybody going to this tiny URL. I only have one more tiny URL for you guys today. We've already, oh, I turned off the name selector. I could go to history. It should still be there. Oh, the groups aren't together. Anyway, so this is what you should see. We're going to another Jamboard. But this time on our Jamboard, we're gonna do this problem. We got group 1, 2, 3, and 4. Obviously, group 1 is gonna be in 2A, group 2, 2B, group 3, 2C, and group 4, 2D. Y'all are all answering the same question, all right? I'm gonna ask the question, and then I'm gonna get any questions from y'all. Do y'all have any questions about the question before we get going? So this is the question. You wanna boil eggs for exactly 9 minutes. But the only way you have to tell time are these two timers, these two antiquated sand timers. That's the only way you can tell time. How could you boil this egg for precisely 9 minutes? Not longer than 9, not shorter than 9. We have to boil this egg for exactly 9 minutes using just these timers. You can start the egg when you turn over the timer. You can start it before, however you want to do it. You can start the timers first, then do the eggs. Come up with it as a group, and I want a solution. And I want you guys to be able to tell me, write out your steps in an easy format to kind of to tell people, because you're going to explain how you did it. Now I'm opening it up. Any questions about the question? You want to boil an egg for exactly 9 minutes, but the only way you have to tell time is those two timers. How are we going to do it for exactly 9 minutes? Thoughts, questions, concerns? I'm curious. I'll hop into some of your breakout rooms if you have questions, but does everybody remember which breakout room you were supposed to be in? Oh, yeah. And now like, no, I don't remember. Well, we're just gonna go ahead on. Just go with your best guess at this point. So pick one, 2A, B, C, or D. So on the side, y'all go to breakout rooms. I can't assign y'all to any sub breakout rooms, I don't think. So I'm just going, you guys have to join it on your own. So I want us to go there, and we're gonna go there for about 6 minutes. I'm gonna hop into your breakout rooms, maybe even longer than that, maybe like 7 minutes or so. I'll hop into your breakout rooms and talk to you, see what questions are arising as we work. But let's hop into our breakout rooms. I only wanna see me in here. I wanna see everybody go to a breakout room. Pick one, 2A, B, C, or D. Or yeah, 2A, B, C, or D. We're not gonna use E. And that corresponds to this Jamboard where you can write out your work.
I can't get into the breakout room for some reason.
Let's see, Lisa.
Oh, choose breakout room. Okay, I got it.
No big deal, no big deal. Thank you for finding it, Lisa. I appreciate that. Y'all let me know if you have any help or if you just stepped away from the computer. Let's talk about it. Let's talk about this particular problem and some solutions we got, and we'll go from there. So where were we? We were here. Okay. So how did we go about solving it? I heard a bunch of flipping and turning to the side, and I heard some good things in these breakout rooms. So let me go to the breakout room real quick. Did anybody write out some stuff? Is anybody here from group D? Because they wrote out a whole thing. Is there a group D representative in here at all? I don't see anyone. Group A, did y'all want to talk about what you did at all? I think this is group D coming back. Group D. You in group D, Gloria, right?
Melissa, we were so gung-ho on trying to figure out the right answer. So sorry.
Okay, talk to us. Tell us what you got in group D and how y'all arrived at this. Can y'all explain this really quickly?
We were going back and forth. We thought we had it, and then we needed a couple minutes. Okay, well, the 7 and 4 minute timer, when they run together, right? That leaves exactly 3 minutes left on the 7 minute timer. When 3 minute runs out on the 4, there's 1 minute left. Use the 1 minute as the start of the boil, then repeat with only 1 minute left again. We were close, but we were trying to go back and forth. I went with a simple one at the beginning, just do the 7-minute timer and kind of eyeball the 4-minute timer to halfway. But that wasn't accurate enough. And then we're like, no, we can do better. We can do better than that.
Okay.
We were trying to do exactly.
It feels like a lot of people started with that same idea of flipping them both at the same time and then bringing it down to like 4 minutes. I mean, to 4 minutes have passed. And now, 3 minutes are left on one and nothing is left in the other. That's pretty much how everybody starts, and everybody maybe should start. So we'll talk about it. This is one way I've seen it done and written out. So they have the total elapsed time in this column. They have the flips happening right here, and they have what it looks like on the bottom. So it starts with both of them. You flip them both. After 4 minutes, as we just said, 4 minutes have passed. There's 3 minutes left in one. Then they flip them again. Those 3 minutes run out, and the 4 minute has 1 minute left, and 7 minutes have passed. So then you flip them again, and after that 1 minute, it falls out of the 4 minute timer. There will be 1 minute that has fell out of the 7 minute timer. And then with 8 minutes left, then you immediately flip it again, because there was 1 minute left in the 7, and it runs out. And that's exactly 9 minutes. I know it feels like, oh, wow, okay, what's going on? This is a lot of little processes. It's a bunch of ways you could actually do this too. There's another way that I've seen people do it. You flip over the 4 and the 7 at the same time. Then once again, you flip over, and it sounded like what you guys were leaning towards in group E. When there's 1 minute left in the 4, that's when you start boiling the egg. And then you flip it over, 1 minute pass, then you flip the 4 and the 4 again. 4 plus 4 plus 1 gives you 9, and you can do it that way as well. This was the moderately easy, hard problem, right? So normally I have people do a second iteration of it. This is a different version of it. It's talking about how much you want exactly a certain number of milliliters in one container. This is a different variation of the same problem. Hopefully they're sharing my slides with you so all of you guys can see this and look at these a little bit later. But all of this kind of leans into this idea of thinking classrooms. I got about 4 minutes left, so or 5 minutes left. So I'm gonna talk a little bit about this. So the way that we do these thinking classrooms has been all the rave. It's a guy named Peter Liljedahl who did the strategy. He starts with a problem. Your problem should be engaging. It could start with a non-curricular type of thing that promotes thinking and collaboration. Later on, you can get to where, we're using like problems from the curriculum. The second thing, visually randomize your groups. Notice what I did. I said, hey, we're going to this thing. We're randomly putting people with different people so you can work together. We try to do no more than 2-3 students per group. Why no more than 2 or 3? Well, because then somebody's not doing work, right? You want everybody to be participating as much as possible. Sit or stand together. We're doing this virtually, but if it was in a classroom, we will be using something called vertical non-permanent surfaces. I'll show you these before we get out of here. We usually use white books. If you've been around Ed Campos anytime, he's a white book evangelist as well. It just means basically whiteboards, where you're standing up kind of at a whiteboard and everybody's writing somewhere where it's erasable, where they can make mistakes and do things of the sort. We usually give 1 marker per group, so they have to talk to each other. By doing that, you defront the classroom. Everybody's all over the room and being able to work together in that way. Groups are allowed to go between each other and go look at other people's work. I didn't ask you that, but I wouldn't have minded if you'd have jumped at another Jamboard and looked at it. And the way we answer questions, we just answer questions that promote people keeping thinking, right? So definitely encourage you to look into thinking classrooms, because that's the thing. But a lot of the work with thinking classrooms has been mathematics. It hasn't been necessarily computational thinking, right? And once again, these are big highlights of using vertical non-permanent surfaces. And this is more data. Like I said, if you had the opportunity to look through my slides, I would encourage you to do so, talking about how students get to work in that way. But we added computational thinking to it. The 4 steps of the computational thinking process are problem decomposition. Take a big problem, break it into little problems. Look for patterns, and then look for abstract solutions to them. And finally, write algorithms that you may be able to use to solve the problem. So I ask you, what computational thinking processes were seen in that problem that you guys just saw? Any thoughts? Of these, did y'all see any of these things that we had to do while you were working?
Pattern recognition.
I would say all of them.
I would have like, I don't think a lot of people got to the part where we were developing algorithms, but I think we did most of the other ones, trying to get abstract. And the abstract solutions part, normally how that looks is I would give you a second problem and that looks very similar and say, give me a solution that can work for like both of these problems. But definitely we looked at problem decomposition and pattern recognition were big pieces of what we did here today. And these things can go directly into computer science. So what computer science topics, I'm not sure how familiar you guys are with CS, but do y'all think, could you see any computer science topics that could have helped you to approach this problem? Anything? All right. Oh, I didn't know if somebody's talking because I'm looking at that. I can't hear if they are. What I would say is this. If I wrote a program, I would probably write some kind of program that's a loop that each time I do something, I have a counter. And my counter is like my two different timers, where one's going to be going out and then it's going to subtract. And then I'm going to have another number that keeps a tally of the minutes passed. And as my loop runs, we're going to keep flipping these things and it's going to keep tallying up how much time. And then it's going to return a value when it hits to 9 minutes and then maybe kind of return what happened in between. I definitely think I could write a program to do this that would kind of walk me through and give me a solution in that way. And look, these are examples of white books. I'm looking at time. They had some other problems that we could have did, but I want to make sure like that we are respectful of time. Whew. 45 minutes went too fast. I'm gonna have to adjust for the next one, but you've been an awesome audience. Follow me on Twitter. I follow back. My name is Mathematic Al. See what I did there? Mathematical. It's a thing. It's a thing. But you guys have been a lovely audience. They're gonna probably rip us out in about 5 seconds. So thank you very much. If you have any questions, feel free to reach out. Definitely, I'd love to keep the conversation going. No, so Ed's gonna close the breakout rooms, not me. Okay, good.
Okay.
Oh, they give us
So
an extra.
if I got a chance to go to the Austin, I may see you in person.
What you coming to Austin for? What's out here?
I'm talking about maybe next when we have the summer break for school, I will have the road trip I planned.
Okay.
Yeah.
Well,
So,
let us know.
yeah, the summertime. Yes. Yeah.
I'm a hop, skip, and a jump, and y'all feel free to come to some of the conferences we throw. I'll definitely share some information there.
Yeah, please, if you have any conference